Okay, hello everyone. We are back after the short break, and I would like to introduce Kristin Weissenberger. She is a senior lecturer and artist at the Academy of Fine Arts Vienna in Austria, and she's here to share her design and research, and especially talk a little bit about fluidic remembrance and olfactory performatic action. So the topic of memory and olfaction already emerged a few times, and now we will have the opportunity to hear how Kristin is approaching it. So can we have her on the screen? Oh, I see Kristin. Hi, Kristin.
Oh, there you is. Hello.
Oh, great to see you. It's evening. Okay, so okay, like the floor is yours. Fluidic remembrance.
Try to share my presentation. Okay.
Yes, we can see you.
Good. Yeah, so hello. My name is Kristin Weissenberger. I'm, as you said, an artist and also senior lecturer at the Academy of Fine Arts in Vienna, Austria. But I'm also part of an association called Pavilion 35, which is a group of creatives engaging in art and science projects. A little bit an overview about my practice. The main question driving my artistic practice is of how we are in exchange with the sphere of matter and organisms surrounding us. In doing so, I focus on the overlapping and relinking of so-called natural, technical, digital, and craft processes. I work with various living and non-living matter, and I also develop new materials such as anthropogenite, where the rock-forming minerals, mica, feldspar, and quartz are fused in a ceramic kiln to create an artificial man-made stone. But I also work with classic and experimental ceramics, bacterial cellulose, mushroom mycelium, or yeast. So my work is a lot about our interaction with matter or material, so short, the surrounding environment. And in this sense, working with smell or scent is particularly interesting, as our ability to interact with scent works completely different than with all other matter. I'm sure you discussed this. But in contrast to all other sensory impressions, the olfactory information from the nose reaches the cerebral cortex directly without first being switched in the thalamus, which is a filter that decides which information is so important for the organism at the moment that it is sent to the cerebral cortex and becomes conscious. Smell is, in that sense, however, outside of this filter of consciousness. So we perceive it differently from all other sensory stimuli. And so they are an independent category of sensory perception. Smells stay in our memory and can often take us back to long ago times or places. They create their own map of experiences and realities within us. And even in the context of matter or material, smell occupies an ambivalent position. On the one hand, it is ephemeral and fleeting, elusive and transient. It disappears like a breeze. Yet it is a disembodied object that strongly influences us. It flatters, warns, and manipulates, transforms, and heals. So I created a performative and participative action to include sand in my installative work. I always work with a group of participants who are invited to take part in a distillation process of a scent of the moment and place. As special scents always stay in our memory, a collectively created smell should generate some kind of fluid sculpture of remembering within the particular group. At the beginning of the action, I try to create a certain mood or spin in the group using text, the singing of a song, or the reciting of a poem. Then we go on a walk together or alone, where everyone collects plants or other smelling materials or materials with symbolic characters, such as hair or the wing of an insect. We meet again in the installation, which includes a steam distillery. In this example, the spatial artwork was as the olfactory sculpture based on the mapping of the meadow and social space surrounding the gallery in Vienna. All materials are crushed in a blender to break them up and get as much flavor as possible. Then I start the steam distillation with the crushed materials, and slowly a smelling liquid drips through hoses or sometimes directly into ceramics or objects of the installation. A scent of the moment, of the place, and of togetherness emerges. And yeah, I always fill parts of this liquid in small glass flasks that the partakers and visitors can take home with them and maybe smell from time to time on them and remember this particular event. So yeah, that's a short presentation of this work.
Thank you, Kristen, for sharing your work with us. I hope we will be able someday in the future to experience this in real life and make this essential oils with you. That would be great. And now we invite Vlasta, who is going to be introduced by Dr. Mershon.
Thank you for introducing the introducer. So it is my great big pleasure, come around, to introduce Vlasta Kubusova. She is a MISTI scholar, and she won a grant to come here to MIT and work with us on sensible biomaterials. And her work combines three-dimensional objects, colors, scents, synthetic biology, self-re-expression kits, olfaction, colorimetry, and you name it. This is the quintessential Media Lab approach. Put everything in and then see what wonders can happen. Please, take it away.
Thank you very much for this nice introduction. So it's a little bit moved down, but I hope it's fine. So thank you, Andreas. So I'm the PhD candidate at Slovak University of Technology, now currently working with Andreas and other people as MISTI scholar at MIT Media Lab, but I'm also co-founder of Crafting Plastic Studio, which is a design research studio in Slovakia, where we explore different bioplastic for value-added products. But today I would like to introduce you to Sensebiome, which is a project where we explore the possibility of creating interactive and responsive biological materials by using synthetic biology methods. So this is the incredible team behind that's composed of designers, bioengineers, olfactory experts and architects. And the project started last year when I came to UPenn to do MOLAB as a Fulbright scholar. So materials are in general mostly perceived by their visual aesthetic and tactility. The olfactory context is very much less present. However, it plays a crucial role, for instance, by identification of the origin of the material. The olfaction also influences our experience in the room, our interaction with the space, and also the interaction with other human or non-human habitats in the space. But olfaction also unconsciously influences our behavior and mood. So the question is if we would experience the space differently when the olfaction would play a big role in it. So this project on the screen was a starting point for me when I really started to get excited about olfaction systems. It's a project by our studio and German architectural office MMK, in which we used the GCMS analysis method to analyze and recreate the smell of primary resources from which we produce our bioplastic composites. We did it in order to create an additional identity for bioplastics, since visually it's almost impossible to distinguish them from oil-based plastics. And this lack of identification within bioplastic industry starts to be quite a big problem for customers, but also, for instance, for a waste management industry. However, this was quite a static solution, and in this project, we started to think a little bit farther, and we wanted to imagine what if we could create materials that are more dynamic and responsive. Are we able to create materials or the new, with the new olfactory and interactive features to help us make our room healthier, to possibly identify the potential threats, maybe to help us react to our moods, or even help us to reduce the stress? So we think yes, and we also think that we might achieve this through the intersection of these three things, which is synthetic biology, biofabrication, and biologically driven materials. So Sensible Matter or Sensebiome project aims to develop and scale these new sensible and responsive biocomposites for product and architectural use. As a first prototype, we decided to work and develop a biomaterial-driven and computer-controlled manufacturing of aroma-active lattices. So we work with biomaterials and polymers, which are mostly used in medical application, and their use in durable consumer products for day-to-day application is quite novel and not fully explored yet. So biologically driven materials are excellent candidates to host and enhance the interactivity thanks to their programmable properties. These plants that we are working with, for instance, include silk fibroin, or other materials that could potentially also preserve the smell longer. At the beginning, we started exploring the integration of living bacteria to our material blends for 3D printing, but since working with living matter brings with it many disadvantages, such as the need of keeping the bacteria alive, the potential contamination, and many more, we decided to work with another option, and that's the cell-free expression system. So this system has a great advantage because it offers a living-like approach while having all the machinery to produce protein from DNA without having all the actual living system around. And we use the cell-free system to bridge the scale of DNA design to material substrates for their expression, activation, and interactivity. So we produce our lattices by using blends that are 3D printed with water-based 2.5 printer for large-scale fabrication. These blends and hydrogels are therefore printed layer by layer, then dry and later fold into lattices. We created this cellular pattern to enable the integration of freeze-dried sample into separate lattice system. So we are working on different genetic circuits encoded in DNA or NAN or RNA. We construct plasmids that contain our desired interactivity and add them to cell-free reaction. So this is an ongoing project. So we try to work with different color, protein, and enzyme expression and enzymes to later add the biomaterial into them, and then freeze dry the materials, cut it into pieces, and later let it rehydrate and activate by either water or substrates. In the future, hopefully in the near future, we would like to also try to express different olfactory receptors to possibly detect various other molecules. So we are now doing a very small steps towards this new dynamic matter, which could adapt, interact with us, and maybe be responsive to its environment. We envision the future of healthier materials that could inform us about the invisible threats, gases, airborne pollutants, help us to balance our stress level by releasing customized smells, maybe attract or navigate insects, or inform us about the air quality and potentially release air-clearing substances. This is a visualization of the installation that we will have next week in Philadelphia at the Institute of Contemporary Arts, where where you are all invited to come. And in this particular installation, we will work with singular molecule with the air clearing capacity. So I would like to thank you again to all this team and the ongoing support from Laia Moga-Soltevila from UPenn and Katia Zolotowski from RISD, and of course Andreas Merschin from MIT. And since you can see that this is very ambitious project, we also hope that through this conference we might find maybe possible collaborators for future. So please let me know if you are interested. Thank you.
Yes. So, thank you for this, Vlasta. I have the first question. I am so happy that we have Aromics in the room. We have Adam Feldman in the room, who's a prostate cancer urologist, amongst other things, and also a co-founder of a startup that wants to sniff prostate cancer from urine. And we have Vlasta in the room, who wants to put olfactory receptors into objects that you can just hold. No longer is it going to be a liquid. So I was wondering, does the future mean that we can have your objects maybe as part of a booth that you walk through, and it smells you and it tells you, it lights up with where your cancer is? If it lights down here, then it's the prostate. If it lights up here, it's the breast. Or other things like this. Assume success. Assume we can do this. Where would you put these things? What kind of applications can you think? You listed so many about mood and health. I want to see what else can you imagine that your materials can do, assuming that they work. And eventually we'll make them work.
So since we started this project with the architects, we are really thinking about the application within the rooms, so somewhere where we can possibly experience the smell or the scent very intensively or more intensively than outside. But we were even thinking of different applications for insects and pollutants outside in exteriors, when it's maybe not related to humans at all, but rather help to maybe navigate them to the place where they cannot come or should come, and so on. So this is one of the options. The other thing that I really like to think about, that's what we also discussed last time, is that this kind of system could enable us to really detect these invisible things that we cannot see. And by then we could maybe really understand or get the navigation, maybe the color navigation about the odors of the ripeness of the food, but also about the degradation level of different materials. So there are plenty of possibilities.
Yeah, I was just wondering, what is the lifespan of these materials?
So these particular materials that we are now working at Penn, that really differs on special blend. Since most of these materials are now being used in medical applications, they don't have quite a long lifespan. But this is also what we are now working on. So here that you can touch later, this is made of our materials, which is made up of PHA-based bioplastics. And this has quite a long lifespan, up to several years. So I think there has to be find this kind of like a balance between the biopolymers that are using in chemical bioplastic blends and the biomaterials to make them durable and for like long-lasting applications.
Thank you.
Unless there's questions from the internet, I have one last question.
And please feel free to touch this later.
Yes, and she has her email up there now, which is a very proud email. She got an MIT email. I'm very happy for that. Vlasta at MIT, please send her emails and questions. I have a question for you, Vlasta. She said something very provocative to me. She said that her materials can help preserve the smell. Now, how important is that for, let's say, diagnostics? If we want to preserve the smell in urine that is telltale of a disease that we want to then present to a machine or a dog, or if we want to preserve historical smells, for the law, for instance. If somebody has I had, actually this happened while I was a TA in my grad school years. I had to deal with this situation where one of my students had possibly some metabolic disease where his body odor was so intense, it would actually literally bring tears to the eyes of anybody sitting within maybe even 10 feet, even more. And when this, this poor person would sit in our giant, bullpen of graduate students where we had all our offices, we could not work there. There was 40 of us, and we all had to leave. So you have no idea how devastating that was to that person and to all of us. And I was having to parse questions such as, this other student is now complaining about their grade, and they're saying that the reason they did badly on the exam is because the smell was so intense. Well, this ends up being a legal issue at that point. So you can record, preserve the smell, and say, and I was on board with this. I was saying, look, we have to have some special accommodation because this person's body odor is just so offensive. It makes other people not able to concentrate. And this person, of course, was completely anosmic to their own body odor. So for them, it was a huge mystery. They were claiming racism. They were claiming all sorts of other things. And I was pointing to my eyeballs. I'm like, do you see my eyeballs watering here? This is what's going on. It's not your fault, but it's also not possible for me to sit here with watering eyeballs trying to tell my students that it's okay for you to do an exam. So preservation of smell has such a great big impact on everything. And it's so ephemeral. We can preserve sound, we can preserve light, we can't preserve smell yet. So your materials might end up being the solution to that. So unless there's more questions, let me introduce the next speaker. Thank you again.
Thank you.
So the next speaker is M. M is potentially an incoming student to even the Media Lab, I hope so. They have done incredible work on olfaction, and they bring this perspective to this that is art and design and hardcore science and even psychophysics, which is not a fake word. It doesn't mean the physics of psychos. It is something that was developed in the last couple of 100 years. There's a very famous physicist called Weber who did these measurements. Amongst other things, he determined what are the sensitivities of the human apparatus for measurement. Psychophysics means the study of the human perception apparatus. So fundamentally, perception engineering and olfaction is part of psychophysics. So M integrates all of these things, and I give you them.
Thank you so much. So hi, I'm M. Doherty. Like Andreas mentioned, I'm a scent artist, I'm a designer, but I'm also a researcher. So my work, I study human olfaction, and then in my art practice, I use scent as my medium, and that could look like a bunch of different things. Sometimes that's mixing specific scents, like perfumery. Sometimes that's scenting spaces, sculptures, installations. Today, I wanted to talk about a device I made as part of my master's at NYU in interactive media. It's called Odor Organ. So we've talked about this several times throughout this conference, that we tend to ignore our sense of smell and like all of the rich olfactory information around us. And although not everyone is, humans evolved to be able to be capable of perceiving and communicating this information, and being able to have a more acute understanding would allow us a clear understanding of our surroundings, our environment, our bodies, our health, our memory, formation, and recall. Scent can tell you about the genetics of those around you, the species in your ecosystem, about disease, danger. It also holds the traditions of foods in a culture. So here was my mission, to help people increase their olfactory literacy, but how? Scent's a wonderful well of information, but like Andrea said, it involves chemistry, artistry, neuroscience, perception, psychology, genetics. It can feel pretty intimidating just to access, but it doesn't have to be. It can be pretty fun to explore. So I wanted to use play as like a joyful, low access point into learning, inviting people to experience, like follow their own curiosity into the world of scent. So that's what I did. As we heard earlier from Joe Paradiso, there's this long-standing connection between scent and sound. It's not just in the temporal qualities of both, the subjective nature, but it's also in the actual language. So here you can see some common words that are used in the practice of perfumery, and also in sound. So sense, accord, organ. In this project, I wanted to use this correlation to my advantage and use the actual mechanisms of music making, specifically the form of piano. So here's the actual organ. So how it works is you play keys, and instead of hearing sound, you have different notes of smell. I chose this form because it's pretty familiar. There's so many different kinds of pianos, from toy pianos to when we're kids, to grand pianos in the hallway. It has pretty intuitive mechanisms, and it's not an intimidating thing to approach and just start. Even if you're mashing buttons, you still understand the mechanisms. You don't need to have any previous knowledge to start. So the organ, I say, is a compact diffusion device that delivers odor notes in synchronicity to music keys. It allows you to play scent instead of sound. So I thought about a couple different use cases. The first of which is for a space for those unfamiliar with the field of scent to just learn more about scent, but the other is for perfumers and scent professionals like myself. This would be a great mixing tool if I'm working on a specific composition of smell, to be able to play different degrees of mixtures. As a perfumer, a great way to find different harmonies that you might not have if you have to add a few drops to each vial. So in the history of scent art, there have been a few attempts at this project. Most famously, Septimus Pies took the musical scale and mapped scents to it. Each note of the piano you can see on the left. And then in 1922, artist Frank R. Paul, inspired by Pies's work, illustrated a theoretical smell organ, but he didn't actually fabricate it. It did inspire other artists since then, and there have been a lot of different iterations on this concept. So this is not an original thing that I came up with. I just wanted to do a modern take on it. So unlike the other multisensory experiences you saw, where it's like a big organ in a room where you're filling a lot of space, this one really doesn't favor more like a bigger audience. It really is optimized for the person playing it, so it's of a more individual interaction. So I started by just taking music, a scale, and mapping different scents and seeing like what would come up, would harmonies arise, etc. It wasn't really clear if that was the case, but this exercise just showed me that like which notes are mapped with what smells is pretty significant to what is possible. So I looked into different categories of scent, and there's plenty. This is 2 examples of the odor wheel, but there's a couple problems with that. The biggest one is that it's limited. It's also like based on subjectivity and bias. So there's like all of these cultural connotations that come up. It's incomplete. You're not going to see, like with a real color wheel, you're not going to see what is the opposite smell. You won't have like specific and equal correlations between the different windows. And there's many scientists that are like trying to crack this dimensionality and lexicon. So I kind of put this down and stuck with what I know, and that's perfumery is where I came from. So in perfumery, you organize notes by how volatile they are. So the fastest things to evaporate are the top notes. middle notes, and the longest ones are the bass notes. So that's what I did, and I just limited myself to materials I had. So this is what I ended up with. So here you can see it being played.
Never have I wished more for it to be able to smell something.
I know. Let me explain. So I'm part of a residency at Boston University in the spring, and I'm revamping this organ. So it's currently in pieces on my desk, and it's not in a place where I had the time to put it back together. But everyone's invited to come to the residency in the spring. That's where it'll premiere. This is just how it was working for my prototype. I kind of hacked into a MIDI keyboard. I used an Arduino to trigger different diffusers. But there was like a couple different problems with this. Like as a perfumer, I couldn't move between materials easily. Like there definitely needs to be a cartridge system. Yes, I wanted the mechanisms of the keyboard, but it wasn't optimal to control things like timing, sensitivities, all the wiring wasn't optimal. I need to redo all of that. So I'm working with a scientific engineer, Dan Gross, to do all of that. That's where I explain why it's not here. Yeah, I mean, it really is. And I'm super passionate about smell. Like, I'm happy to talk about it anytime and all the time. So please reach out if you have any questions or just want to nerd out a little bit. Thank you so much.
Thank you. Questions for Em and Carolina, can you prep the next speaker?
I have it.
They're going to. Oh, you have it. Okay. So questions for Em. Oh, there it is. Emmett has a question for Em. I love it. Here, let me give you the mic. But it's for the web. Oh, there's a lot of people on the web.
Hi, I love your presentation.
Thank you.
I'm curious if there were any meaningful physical correlates that you found when you were trying to map sounds to scent. Because I'm thinking, for example, about like the overtone series and spectral music, and when you were talking about the duration of certain scents in perfumery, it made me think of like fundamental frequency versus partials.
Totally.
And I'm just curious what your thought process was for
I
that.
don't know enough about music theory. This is like one point I came to, trying to like take, there's like different rules of harmonies in music, and it would be lovely to see if those mapped directly, but I didn't know enough, so I tried to avoid the synesthetic kind of experience and focus more on letting people see the temporal qualities of smell on their own. I think it like highlights that more so than saying this smell equals this note in a way. I think that is kind of a misnomer and super subjective, and it kind of detracts from just like smelling out what's possible.
Thanks.
Yeah.
I'm inspired to ask you a question that I used to use as a demonstration of how to not construct questions. And the
Cool.
question is, what does Mozart's music smell like? Equally, you can ask, what does Mozart, what color is it? So that's where the synesthesia comes. But if I do ask everybody here, what color is Mozart's music, assuming you know it, to me, it's quite clear that it's pink and peach. I do not
I
know
would've said blue.
why that's unclear to other people, but of course, that's where the subjectivity comes in. Other questions?